Hello and welcome to my YouTube channel. This is a basic introductory video of the neurology series in which I will cover the concept of the action potential in the neurons. This video has been divided into two parts. In the first part of the video, we'll understand the concept of the resting membrane potential, and in the second part of the video, we'll look at the actual generation of the action potential. So let's cover the resting membrane potential first. So what is the resting membrane potential? See, what happens is that at the resting state, there is a separation of charge across the neuronal membrane. Because of this charge separation, a potential is created across the membrane, which is called as the resting membrane potential, and this value is about minus 70 millivolts. Now let's see how this resting membrane potential is generated. So if we look at the neuron, there is a high intracellular potassium and there is a high extracellular sodium. Also, we have a potassium channel on the neuronal membrane, which is actually a leak channel, which means that it drives the potassium from the inside to the outside of the neuron, because potassium is potassium is high inside and low outside. So as soon as the potassium moves outside, we see a separation of the charge. Since the positive is moving outside, therefore it leaves the negative inside, and hence the charge separation takes place. Similarly, there is also a sodium leak channel which tries to bring the sodium from the outside to the inside of the cell, and this will try to break the charge separation which is produced by the movement of the potassium. So here we have to understand the role of the sodium potassium ATPase pump. This pump uses the ATP and it moves 3 sodium molecules outside and brings 2 potassium molecules inside. As a result of this, it brings a net negative charge inside the cell and will maintain the charge separation which was being interfered by the sodium coming into the neuron. So in this way, the resting membrane potential of about minus 90 millivolt is created. Now let's see the second part of our video, that is the generation of action potential. So to understand the action potential, we have to look at some more ion channels which are present on the neuronal membrane. The first of them is the voltage gated sodium channel. This channel is inactive at the resting state, and as the potential rises to about minus 55 millivolt, these channels open and large amount of sodium flows into these cells. So guys, this potential is called as the threshold potential. Also, we have the voltage gated potassium channels. Again, these channels are inactive at the resting state, and when the potential rises to about plus 30 millivolt, these channels open up, and when they open, large amount of potassium flows from the inside to the outside of the cell, making the potential negative. Now, when the stimulus is applied to the neuron, this causes the opening of some of the sodium channels, as a result of which the sodium moves into the cell and it raises the potential. As this potential reaches to about minus 55 millivolt, the voltage gated sodium channels get opened. This causes the rush of the sodium into the cells, and as a result of this, the potential will increase and we say that the cell is depolarizing. Eventually, the voltage reaches up to the plus 30 millivolt. So these sodium channels become inactive and the potassium channels become active. This causes the rush of the potassium to the outside of the cells, and therefore the inside of the cells become negative. And there is a drop in the potential and we say that the cell is repolarizing. Therefore, the potential begins to fall and reaches the resting membrane potential. Ideally, these potassium channels should close as the cell reaches minus 70 millivolt, but these channels stay open for some more time, which causes the efflux of more potassium, which brings the potassium below the resting membrane potential, and it makes the potential more negative, which is called as the hyperpolarization. But as they close, the sodium potassium pump works again to bring the potential back normal. Let's see how this action potential moves. See, as we cause the depolarization of one of the segment of the neuron, the positive charge from the one segment moves to the next segment via the local current, and it increases the potential over there. So as the potential reaches to the threshold in the next segment, the sodium channels in that segment of the neuron open and initiate the action potential. And in this way, the action potential from one end of the neuron reaches the other end. So guys, this is all about the neuron action potential. I hope you liked the video. Please do subscribe to my channel to watch more videos like this. Thank you.